starting Unit 6, which is our first of 2 units on trigonometry. We're going to spend the first part of this unit looking at a new way of measuring angles called radian measure, and we're going to spend the later half of this unit looking at some more trigonometric identities like the ones you learned in grade 11. So today we're going to look at radian measure, a new way of measuring angles. What I'd like you to do tonight, as you're watching the video and afterwards, is brainstorm, or if you want to, do a little bit of research about why we measure angles in degrees. Why have you spent all of your mathematical lives up to now measuring angles in degrees? And we're going to start tomorrow's class with a little bit of discussion on this. So let's look at what a radian is, and you can follow along with this. But in your notes, draw a circle. Okay, and you can see I've got one drawn here. On your circle, draw a radius. Okay, I've included one in my diagram. Next, try to draw an arc along the circle that has a length equal to the radius of your circle. Okay, so you should have been able to draw this arc. I'm having a little bit of trouble on the smartboard. We should be imagining the line that I've drawn covering that arc of the circle. Okay, so the best I could do on the smartboard is that rectangular box there. You should have something drawn along the arc of the circle. And now that you've done that, connect the end of your arc back to your original radius. Okay, so my last step, like I said, I'm going to create a little pie piece by connecting the end of the arc to the center of the circle. And what I've drawn here is a unit of measuring an angle. And this pie piece that I've drawn is equal to 1 radian. So following this same set of steps, try and figure out how many radians in one circle. So take your pie piece and create another one, and another one, and so on, all the way around the circle. If you've done that properly, what you should see is that you end up with 6 full pie pieces in your circle and a little bit left over. So in one circle, there are 6.28 radians. Okay, think about that number 6.28. Can you think of any numbers that is similar to? 6.28 is approximately equal to 2 pi. So let's formalize this a little bit. The radian measure of an angle in a circle is defined as the length of the arc, A, that is in between two radiuses, or in between two slices of a pie. That angle theta then is equal to the length of the arc, A, divided by the radius. So if we go around the circle one whole time, if our arc length is equal to the circumference, then the angle theta would be equal to the circumference of a circle, which is 2 pi r, divided by r. The radiuses cancel each other out, and we're left with an angle of 2 pi. So one complete revolution around the circle measures 2 pi radians. So let's now look at finding out a relationship, if one exists, between radians and degrees. To convert radians to degrees and degrees to radians, well, for radians to degrees, we know that 2 pi radians equals 360 degrees. Degrees to radians, we know that 360 degrees equals 2 pi radians. So in both cases, I can divide both sides by what's on the left-hand side of my equal sign. So here I'm going to divide both sides by 2 pi. And I find that 1 radian is equal to 360 degrees divided by 2 pi. And likewise, 1 degree is equal to 2 pi divided by 360 degrees. Simplifying this, 1 radian is 180 degrees divided by pi, or about 57.3 degrees. And 1 degree is pi over 180 radians. So 1 degree is a very small piece of 1 radian. It's 0.0175 radians. And just something to know, abbreviated rad is the unit that we use for radians, but we often don't even include rad when we're talking about radians. So if we have an angle with a degree symbol, we understand that's using our normal degrees that you've learned up to this point. An angle with no degree symbol, or no symbol at all, like 6.28, is understood to be measured in radians. And we're going to start working in exact angles. So exact angles are usually written in terms of pi. As an example, a straight angle, something that's 180 degrees, is referred to as pi radians. Okay, let's look at some ways that we can apply this. If I have a degree measure of 30 degrees, I'd like to figure out an exact and approximate radian measure for 30 degrees. So here, 30 degrees is equal to 30 times pi over 180. I multiply by pi over 180 because this is equal to 1 degree. Pi over 180 is our conversion factor. So I end up with 30 pi over 180. Don't multiply out by pi. Keep it exact. And then I can reduce this fraction. How many times does 30 go into 180? Well, 30 goes into 180 6 times. So 30 degrees is exactly pi over 6 radians. And if I take that value pi and I actually divide it by 6 on my calculator, I get about 0.52. So the approximate answer So I can say that 30 degrees is approximately 0.52 radians. And you can try this on the graphing calculator. Okay, another question. Now we're converting the other way. We're going from radians to degrees. So I have pi over 4 radians, and I will multiply this by the conversion factor to convert to degrees. So 180 over pi. And again, some things cancel out. Pi terms cancel out. So I'm left with 180 over 4. And 180 divided by 4 is exactly 45 degrees. Similarly, I can take that radian measurement of 5.86 and I can multiply it by 180 over pi. And I do this in one step on my calculator, and I'm going to get about 335.8 degrees. Okay, here's an example of a word problem, an application problem involving radians. So someone's on a carousel. So imagine carousel is a circle. They're on this camel that is 9 meters from the center of the carousel. The carousel is turning through an angle of 5 pi over 6 radians. And we'd like to find the length of the arc. So how far around this carousel this person will have traveled if the angle is 5 pi over 6 radians. So remember that our radian measurement is equal to the arc length divided by the radius. So if we know theta, 5 pi over 6, it's going to be equal to A over 9. Cross multiplying, I'll have 5 pi times 9 over 6 is equal to the arc length. If I plug that into my calculator, I get about 23.6 degrees. If I plug that into my calculator, I get an answer of about 23.6 meters. One final example and one final application of radians that we'll be looking at, something called angular velocity. So the angular velocity of something is equal to its change in angle divided by time, or its change in time. So in part A, if my hard drive is rotating 7,200 rotations per minute, well, I need to figure out how many degrees that is. So a hard drive is a circle. So one rotation would be 360 degrees. 7,200 rotations would be 2,592,000 degrees in 1 minute. So the angular velocity is going to be 2,592,000 degrees divided by 60 seconds, because we're trying to find degrees per second. So this works out to 43,200 degrees per second. Part B is asking us to do the same thing, except this time it's asking us to do it in radians. So this time, instead of multiplying 7,200 rotations by 360 degrees, I'm going to multiply it by 2 pi. And I get 14,400 pi radians. So this hard disk has rotated that much in 1 minute. So we can take that number and divide it again by 60. And I get an angular velocity of 240 pi radians per second. So just to summarize, we defined today what a radian is, and we're going to look more at that definition tomorrow. This is important. A radian is found by taking the arc length of a circle in a pi piece, okay, cut into a pie like this, and dividing it by the radius of the circle. And also important, converting between radians and degrees can be found by, well, if we're converting to radians, multiplying by pi over 180. If we're converting from radians to degrees, multiplying by 180 over pi. Okay, remember please, I want you to bring to class some thoughts on the question, why do we work in degrees? And that's all for tonight. Thanks for watching.